All right, video 2 here, transformations of quadratic functions. We are now going to look at horizontal transformations. So in the first video, we kind of talked about how just by having something that's y equals x squared, if we just added something to it, and we'll call that k, it would basically move this up or down depending upon what k was, whether it was positive or negative. Now, in these with horizontal transformations, and if you think about this last example here, it was a vertical transformation. It moved it up and down vertically, right? If it's a horizontal transformation, it's probably, if we're gonna use a little intuition, it's probably gonna move it from left to right. And you will indeed see that that's what happens. So the way these are written, and we use slightly different notation, is we're not going to use k again. We're going to use h because we're going to use h and k for something later on. All right, later on in this lesson. So we're taking our parent function, our f of x equals x squared, and what we're doing is we're going to, within the quadratic term, which is the term that's squared, we're going to take something away from x, or we're going to add it to it. And we're going to kind of see what that happens and how that happens. All right, so the one quick thing I want you to notice is that the general form for the vertical was plus k, and this one is minus h. And so this kind of threw me off a little bit when I first learned about this. So hopefully we'll be able to kind of explain this to you. So again, we start with our graph, f of x equals x squared. So let's throw you right into the fire here. We've got g of x, and we're going to say this equals x minus 3 squared. Now, if you look at this, right, I know that I'm not moving this up or down, so my vertex is going to be along this x-axis somewhere, right? And they told me it's a horizontal translation, so it's going to move this one way or the other. I don't know which way yet. I don't know how much. But we're going to kind of look at some things. So if you just look at this from a plotting point perspective, if I decided, okay, I'm going to take this and I'm going to put in 0, right? If I put 0 in, I have 0 minus 3 squared, right? Which would be negative 3 squared, which would give me 9. So when I put 0 in, that moves me all the way up. I got a point suddenly that's right here. Well, if I put 1 in, right, and I got 1 minus 3 squared, then I get negative 2 squared. I should probably put parentheses around those, which would give me 4, right? So I got a point here. And then if I put 2 in, 2 squared, or 2 minus 3 squared, it gives me negative 1 squared, which is 1. So guess what happens if I put 3 in? Well, 3 minus 3 is 0. So I don't know if you're seeing this, but basically what's happened here is our parabola has just shifted over. I do that really badly. I apologize. I'm using this like homemade stylus that I made, and it does weird things. So we've got a parabola that if I continue to plot it is going to move that way. And basically what happened is my vertex shifted over to the right 3 units. Now what's hard about this is because if you think of the way the other one was written, because it's x minus 3 squared, I wanted to think, oh, that means I'd go over to negative 3 for my x. No, it actually, because the form is x minus h squared, where h is my new x coordinate of my vertex, right? Which is this bottom part right here. So, and it doesn't say negative x, it says x. So if it's x minus 2, my new x coordinate would be positive 2. If it were, and then you'll see we're going to look at an example what's going to happen if we're adding something to it. So start with the same thing right here. We're going to use g of x equals the quantity x plus 2 squared. Well, if I put 0 into this again, I like to start with 0. You get 0 plus 2 squared, and that's going to give me 2 squared, which is 4. right? So 0, 4, which is my point right here. If I put 1 in, that'll give me 1 plus 3 squared, and that's going to give me, or 1 plus 3, no, 1 plus 2 squared, God. Can't add. 3 squared, that's going to give me 9, all right? That's going to put me up here, and obviously as my numbers continue to get more positive, they're going to get bigger and bigger. So again, what's happened is this thing has obviously shifted. Let's see how much has it shifted. Well, if I put negative 1 in, you have negative 1 plus 2 squared, which is 1 squared, which is 1. So a negative 1, 1. And then if you look at it, what do I have to do to make this term 0? Well, I put negative 2 in. When I put negative 2 in, it makes it 0 squared, which is 0. So this has taken this whole thing and shifted it this way. All right, so just like the other one, and I apologize about how bad my parabola drawing is, but just like the other one, this has moved it h units either to the left or to the right. And for this one, if it's x plus 2, and it's supposed to be in the form x minus h squared, well, if I put 2 in there, if I put a vertex of negative 2 in there, x minus negative 2, that's how it becomes positive. And that's how it becomes positive 2, right? So h is your vertex point, it's your x point. If you have x plus something and you're squaring that whole thing, it's going to shift to the left. If you have x minus something in there, it's going to shift to the right. So if you can't remember that, just always start by putting 0 in and some points next to 0 on the left and right of it, just to kind of see the general movement of this, and I think you'll be able to figure out, oh, it's going to the left or right. So that's our that is horizontal translations for you, just moving it to the left or to the right depending upon what that number is inside the parentheses with the x.